Now in this section we're going to now talk about the second step of the three-step process of organizational intelligence, which is analytic intelligence. And in this phase of in this step, we take the data that was collected from the data intelligence people. So remember, those guys gathered a bunch of facts and shoved them into a relational database. The job of this part is to take that data and to turn it into information that can be used by the organization. So just collecting a bunch of facts doesn't mean a lot, but when you have to extract information from it, that's when the value can be achieved. Now, the analytics intelligence people really have several types of analysis that they're going to do on this data. One type is going to be statistical analysis, and that's going to be something that, for example, in a drug study, when you have to have a lot of mathematical rigor behind your analysis, that you're going to say, yeah, I have a very high confidence that this drug is going to be effective and not going to harm somebody. Predictive models is more practical application of mathematics, and this is where I don't particularly care if this is a mathematically optimal solution, but it's better than what I'm doing now, and I'm going to make money with it. So as long as I don't care if I have to squeeze every last drop of information out of this data, if I can get something quick and get it into production so I can make money, that's the value. That's what a predictive model is for. Segmentation is when I can take groups of data and put it into buckets and learn something new. For example, if I have a bunch of animals and I say, well, I don't know anything about animals, but I can observe that some animals are fuzzy or furry animals, and I stick them all in a bucket and I kind of look at them, and then I put the ones without fur in another bucket. Well, I then begin to realize there's a pattern of the ones that have fur or fuzzy skin. Those ones are warm-blooded and they can handle cold weather. So that is so that's because they're warm-blooded, and warm-blooded animals can handle cold, whereas the ones without fur are reptiles and they cannot handle cold weather. Now, I can't look at an animal and know what its blood is like, but I can observe one thing and learn something new. So segmentation is a very important process of analytics intelligence. Another type of analytics that is done by this group is text mining or natural language processing. And what happens is a lot of times an organization will receive a lot of text, which is called unstructured data. That's another word for text. And you get this unstructured data and it comes in there, and you can't read 50,000 emails every day. But what you can do is look for mathematical patterns in the words. Certain words will come up over and over again, and you might be able to guess what the topic of the email is, for example. And if a person is emailing you a letter and you're a customer service and you don't know where this email comes in, and you have to say, well, this person is using a lot of angry words: bad, angry, irritated, cancellation, words that should raise red flags that this customer is about to leave. And then they say something like service, rude, angry, inconsiderate, or whatever. So even if you don't know what this email is about, you can just look at certain words, and these words would say, well, this guy's mad about bad service, and the computer can forward this email to the appropriate department and maybe save a customer. So another function would be trend analysis, and you can look at data over time, and you can try to figure out patterns of things, like certain trends, like more people tend to get on the airplanes in the summertime than in the wintertime, or over time more people are getting on airplanes. And so you can look and try to figure out, and this allows you to forecast and run your business if you can tell ahead of time by looking at past data. So the techniques or the methods that are used by the analytics intelligence people to do those previous functions, regression is one of the main areas of statistical analysis. So the data is collected, and regression analysis, and a lot of people are familiar with regression from high school or maybe a college, an undergraduate statistics class that's required, where you just try to build a regression model. Now, the difference between regression and the next part, which is machine learning, is that regression tends to have some highly rigorous tests after you build your model to see if it's the best possible model. You know, you can do an ANOVA analysis and look to see if your model is statistically significant and is there any patterns in the errors. That's the type of thing you're going to do in regression. Now, machine learning is more of a trial and error process, and we'll talk more about this in a subsequent video, but machine learning is a trial and error process, and you don't necessarily are going to be guaranteed to getting an optimal answer. You're just going to get a better answer than what you're doing now. And incidentally, regression can really be a machine learning process as well. So a lot of times people will be building predictive models with using machine learning techniques, and they'll throw a bunch of regression analysis in there, and they will relax a lot of the statistical requirements from what they learned in school, and they're like, well, this may not be the best regression model, but it's better than what we're doing, and we're making money with it. So regression can be really considered another type of machine learning technique. Clustering is, remember what I just referenced a few minutes ago about the segment where I can put like fuzzy animals in a bucket and scaly animals in a bucket. That would be just something I can observe with my eye. However, cluster analysis is a technique for putting things in buckets mathematically. So if I look at your income and your age, for example, and I start graphing it on a two-dimensional plot, I can might be able to find clumps of data. So it's a mathematical way of putting things together. Time series analysis is the mathematics behind looking for trends, and that's there's a lot of techniques behind that where you can look at time series data and say, well, I can now figure out that the number of people getting on the airplane in June of 2010 will be very highly correlated to the people getting on an airplane in 2009 in June. So you figure out that there's like a yearly trend analysis. You know, you can also have like a seasonal effect, which is the month, and also a trend. So I look at how many people got on the airplane last month and last year at this time. So there's a lot of math behind that, and we'll go into greater details throughout the course. Some common analytic tools that are used, probably the most widely used would be SAS. And SAS has been around since the 1960s, which is why it is most widely used. It happens to be very good at doing data preparation work. So I collect a bunch of messy data, and the data never falls out of the sky, blessed by the fairy princess. It's ugly, messy stuff. And SAS happens to be particularly good at preparing that data so I can do my statistics and my machine learning and my clustering. So it's good at scrubbing it, and it's also really good at doing the analytics on the data. And when I'm done, I can take that SAS and write standalone code to deploy a model. R and Python are open source tools that allow people to build predictive models, and they are growing in popularity and usage. And a lot of kids in college are exposed to R and Python even more than SAS at this point. So they are, if they haven't passed SAS at this point in utilization, it could happen in the near future. Just because the price point of these two languages, R and Python, are hard to beat when it's free. There's obviously R and Python can do things better than SAS, otherwise they wouldn't exist. And also SAS does things that are better than R and Python, otherwise SAS would not exist. So these are probably the three primary tools, and we can go into more detail as the quarter progresses as to the advantages of all of these things. But these are the tools that you are most likely to encounter. Now, you also, one of the new things that is also beginning to become more prominent is a model factory tool. And this is for people who are non-practitioners of analytics and they want to build models en masse. So this would be something like if I wanted to predict who's going to buy Twinkies, for example. And I believe that everybody in each zip code will behave differently. As opposed to me building 100,000 specific models for each zip code, I can throw the data in and a model factory will build 100,000 logistic regression models, for example, one for each zip code. Now, these won't exactly be the best models ever, but they will be very good models, and you can't let perfect be the enemy of very good. So these model factory tools are very useful, and they're gaining wide usage in some areas. Other tools that you might encounter is SPSS and Angus and Salford systems. These are 3 modeling tools that you will also encounter in corporate America and in academia and a few other places. You won't encounter them as much as SAS or R or Python for a lot of reasons. For example, in the case of Angus and Salford systems, they just were smaller companies, so they tend to find niche players. Like Angus, for example, tends to be seen a lot in the banking world. It's used in other places, but it had some advantages that made it attractive in banking, which is where it got a lot of its foothold. SPSS is another very good tool. It was a preliminary, or previously as its own company. It was purchased by IBM. So I think that there's issues right now where SPSS is as the making of this class, SPSS is trying to being integrated into the IBM product line. So I don't see that. As of 2016, when this course is being made, I don't see that that product as much as I used to see it, but I'm sure it will have definitely a real future. There's other specialty products that you will encounter, like Zeno and Emblem would be 2 good examples. Zeno is a product that was designed for building credit score models. So, like Fair Isaac will give you a credit score like 740 or 820 or 630 or whatever. That Zeno is a tool that builds that type of thing. There's other tools that will do it as well, but Zeno tends to be widely used for that. And so banks will use it. They'll bring it in. They can use it for other purposes, but it's like an Indianapolis 500 race car. It has a very specific purpose, and it does that purpose very well. Emblem is a similar product for insurance. It's very good at building generalized linear models to predict risk, and you will encounter that a lot in the insurance industry. So this is just some types of tools that I want you to get in your mind, that if you hear these things, they make sense or they're familiar terms to you. Other functions of the AI world, or analytics intelligence, is validating models on holdout samples. Now, what will happen is a lot of times people will build models, and you might just because the model performs well on the data that you built the model with. So I've got a training data set, I build a model, and the model could be a machine learning or a regression, and it does really well. But the proof of the model is when it performs well on something that it's never seen before. So that's called validation. You want the model to perform well on new data before you have any confidence in using it in your corporation. Deploying the model. Once you've validated the model, typically the analytics group, not always, but typically they will be in charge of writing a score program which will score new data. So it's usually a standalone program that will be given to the data intelligence people, and it will be written in SAS is a common one, maybe SQL, maybe Java or C, or perhaps PMML is another language. There's ways to deploy the model, but you want to be able to score new data, and it's usually their job in the analytics intelligence to deploy this model. Monitoring production models and watch for performance degradation. So what happens with a model is over time a model begins to go bad, and that means that if I build a model and I'm trying to predict who wants to buy cars, and I built that model in 1955, I might say that the perfect income for a guy to buy a 1957 Thunderbird is $5,000 a year, because that guy's got a lot of money. Well, over time, that income is going to be no longer valid. The model will not perform. If you have a model from 1957 and you put it into today's world, $5,000 income is not a lot. Kids make that just delivering newspapers. So you have to watch your model and begin to realize when it goes stale. Now, not all models go stale, but a lot of them do. So it's the job usually of the analytics people to know when the model starts going bad and then to refresh it or build a new model. Finally, because these are the guys who built the model, they usually are the ones who have to document it, because there's a lot of government regulations in many of these models or internal requirements of the business. They say, hey, how do I know that there's not been any illegal discrimination in this credit scoring model? Well, the analytics people have to document everything they did and why they did it, so that the government, if they come in and audit you, they can find out that there was not any sort of illegal variables or illegal discrimination going into the model. And there could also be business reasons as well, but you document what you did so that in case something happens or the analytics person leaves, somebody else can either A, see what happened with the model, what's going in there, or also if somebody else ever wants to refresh the model, they can see what paths the analytics person went down. They can say, okay, he's already tried a neural network here, it didn't work, therefore let's not even walk down that path. So those are the functions of the analytics intelligence part of the three-step process. And we'll go into some of the terms in another video.